and this is the second flipped class activity video 2, and in this video we will explain about types of operating systems. And here present is Kranti Kumar, Ramakrishna and Bhimalingappa. Next, here the contents are types of operating systems like simple batch systems, multi-programming batch systems, multi-processor system, distributed operating system and real-time operating system. So in simple batch systems, here in those days in olden systems, assumption is there is no operating systems, and here by using a tape drives or punch cards, we are giving the data through punch cards to the your hardware device. Your hardware device accept those punch cards and process it and give it back. That is sequential manner. Once we are giving a job to a particular hardware resources, then it cannot take other job until it completes the job one. Due to this, it is not possible to execute multiple tasks at a time. So the disadvantage of simple batch system is zero interaction between user and computer and no mechanism to prioritize the process. And next, and multi-programming batch systems, here we are providing an operating system. Operating system responsibility is in multi-programming means how can we execute more than one program at a time by a processor. Here assumption is processor can execute more than one task at a time in a given interval of time. So the operating system responsibility is it enhances the performance of the processors compared to the previous system. Here we can execute more than one task in interleaving fashion by using a CPU scheduling algorithms. And in non-multi-programming system, there are moments when CPU sits idle and does not do any work. For example, in sequential execution, maybe your program contains something related to execution purpose and something related to printing purpose. So once the execution part is completed, then we are giving the task to the printer purpose. At that time, the processor keeps idle. That is, in sequential manner, if job 1 is completed, then only we go for the job 2. But in case of multi-programming, if program 1 is executed by the processor and some of the part of the program 1 may be related to the IO systems, at that time CPU does not sit ideal. It can execute to the, it can give a chance to the processor. So the main advantage of multi-programming system is there is very few less idle time of processor and utilizing processor very well. In one second part of the multi-programming is time sharing. The main difference between multi-programming and time sharing is in multi-programming we are not concentrated on whether we are executing all the jobs or not. The only thing is whether CPU is busy or not. In case of time sharing, we have to look up into whether we have to set the all the processes available in the ready queue or not. That means response time is very important time sharing environment. And for example, if you take the multi-program example, in uni-programming, here program will run first and the entire time is waiting here, and I can go for the second program. In case of multi-programming with two programs, program A and program B, here this type of execution is called interleaving execution, and program A executes this much of time. At that time, the in between the waiting stage of program A, we can accommodate the waiting ideal time of processor to a program B. So in this way we can execute A, B at a time. If we consider multi-programming with the three programs, so when we are enhancing the number of programs, when we are increasing the number of programs, we can accommodate more number of processes and we can improve the throughput. Throughput means the number of programs or instructions are executed by the process in a given unit of time. Next, in advantages are there, enhance the performance and multi-processor systems. In case of multi-programming, assumption is only one processor can execute more than one task at a time. To improve, to enhance your job very efficiently, to faster work, we have to provide more than one processor in a system. That means in recent years we are called as dual core, octa core and hexa core. That means in a single chip we can accommodate multiple sockets, and in multiple sockets we can accommodate multiple processors. That means a single processor can execute more than one task at a time. If supposed to be your hardware contains 4 cores at a time, that means we can execute 4 processors and 4 multitaskings. That means we can enhance your performance compared to the multi-programming environment. In case of distributed operating system, we are that means here we have provided multiple computers. supporting multiple processors and each process supporting multitasking. That is, compared to multi-programming, multiprocessing is efficient. Compared to multiprocessing, distributed operating system is very efficient. And last one, real-time operating system. Here we need, here in industry we can use these type of real-time operating systems. Here main thing is we need to work on critical operations only, because we have to perform more number of tasks at a time. But here the thing is which programs are very important. We have to prioritize which are more critical problems and which are not, and we have to work it on more critical problems only. And even though in real-time operating system we have two types of real-time operating system, one is hard real-time operating system and one is soft real-time operating system. In hard real-time operating system, first we have to prioritize a critical task, and we can assure that that particular important task is must be completed in a given schedule time, that is on time. In case of in soft real time operating system, here also we can working on we can work maximum time on the critical tasks only, but here we are not giving any assurance to whether those tasks are completed in a different manner in different time or not. So this is something about the types of operating system. Thank you very much.